So for this lecture, we're going to look at how we can use a pointer to assign values to an array and how to use the pointer to navigate the array to read the elements that we've assigned into the array. So let's start here. Let's say this is memory, right? So this is memory here that is available for us whenever we declare local variables. Let's say we do something like this, int AR, and this time I'm just going to use 3 elements in there, semicolon. So what happened here is that, let's say it started right here. That's the first address. And let's call that address, let's give it a number, 1028, right? So let's say in memory, that's the actual physical address. And it started right here. So we'll have 1, 2, 3, 4. So 1, 2, 3, 4 for element 0, the first element. Then 1, 2, 3, 4 for the second element. And the final last element will be here. 1, 2, 3, 4. And here we go. So all of this space will be reserved for this array. Now, this particular address, okay, this particular address, 1028, is the starting address. The next address is 1029. The next address is 1030, 31, 32, 33, 34, etc. But when we're going to use a pointer, we're going to move 4 bytes at a time. So we're going to go from 1028 to 1012 right here, right? And then the last one will be at 28. That would be at 32, and then the other one will be at 36. Okay? All right, so how do we express this address? There are a couple ways we can express that address. Either AR 0, we know it's the element 0, and we put an ampersand. Just write down the ampersand a little better. Okay, just like any other variable you've seen, expressing what is the address of A, for example, ampersand A. So ampersand AR0, or AR simply. The name of the array is the first address of the array. This is going to be very important to know that. So the name of the array is the first byte address, or where the first byte is located. Otherwise, you could use the first element physical address. This is an ampersand, by the way. AR0 is going to be that same value as AR, which is the address right here. Okay, well now, I mentioned that I wanted a pointer. So let's create a pointer here, int asterisk, and let's just call it PTR. Now you need to assign it. So if I put a semicolon, it's just simply a pointer. So again, so if I put a semicolon here, then it will be, it will take 1, 2, 3, 4 to store an address, an integer address, and this would be PTR. So it's somewhere in memory, somewhere. What we want right here in this space is that 1028. So now we know the pointer will be pointing at the beginning of the array. So you could either do this, PTR equals AR. Aha. So all you have to do is make PTR equal AR. And that way, 1028 will be stored in there. Okay? The alternate to this is to do PTR, again, and percent AR 0, semicolon. Okay? What you're not going to be able to do is PTR equals 1028. And the reason for that is you have no clue or no idea what that address is when you're running the program. And you're not guaranteed that address every time you run the program. So you always reference to that address. You don't access it directly. Rarely do we do this. We only do this with ports, for example, for an input-output port address. Well, those are fixed. No matter what your computer, when you turn it on, you turn it off, come back, port 0, port 1 will always have a specific address that you can actually point to. But that's not the case here. All right, so you're always going to use some sort of a reference, either the name of the array or the address of the first element of the array. So now, if you do something like this, printf, or I'm sorry, not a printf. Let's say you want to assign a value, and you do something like this, asterisk ptr equals 8, semicolon. Then what's going to happen is 8 will be stored in the first element. And the reason is because your pointer is pointing to the first address, the first element. So it's going to take that 8 and store it right here. Now, how do I move to the next one? Well, you're going to have to increment your pointer. So you're going to take your PTR, and you're going to make it equal to the old PTR plus 1. And you're going to say, wait a minute, we need to move 4 bytes at a time. Aha, that's your resolution. That 1 here means you're moving, since it's an integer, you're moving 4 bytes at a time. Very important to understand that. So that 1 is not really, you're not adding 1 to 1028. You're adding 1028 in the background plus 4 bytes. Okay? So what is that? 1032, right? Right? So that's where the next address, or your pointer now, no longer has this. It has 1032, which means now this pointer is pointing right here. Okay? And now if you do this, asterisk ptr equals -1, then what happens is -1 will be stored within those 4 bytes. There's another shortcut for this term here. You could use ptr plus plus, semicolon. So these two are equivalent statements. So right after that, if you did ptr plus plus, what happens is you're going to add 4 bytes to this, right? And that would be a 6, 1036. And 1036 means your pointer now has that value, 1036, and it's no longer pointing at 1034, but it's pointing at 1036. This is address 1036. And if you dereference it and you say PTR, and let's say you store 22, semicolon, then your 22 will be here. Then we're going to use this pointer to be able to retrieve the data as well. Okay, good. So we're going to be doing that. We're going to be coding all of this in our next video.